Good day, everyone. I will be discussing chapter 44, which about correlation. There are many instances in our lives when we try to determine if some characteristics are related with each other. On a higher level, we want to measure the degree of the relationship or association. We usually associate height and weight, budget and expenses, mental ability and academic performance, sibling order and attitude, and other aspects of life which may be related with one another. So, what is correlation? Correlation means association. More precisely, it is a measure of the extent to which two variables are related. There are three possible results of a correlational study. First, positive correlation. Second, negative correlation. And last, no correlation. A positive correlation is a relationship between two variables in which both variables move in the same direction. Therefore, when one variable increases, as the variable increases, or one variable decreases while the other decreases. An example of positive correlation would be height and weight. Taller people tend to be heavier. A negative correlation is a relationship between two variables in which an increase in one variable is associated with a decrease in the other. An example of negative correlation would be height above sea level and temperature. As you climb the mountain, of course, there's an increase in height. It gets colder because the temperature decreases. A zero correlation or no correlation exists when there is no relationship between two variables. For example, there is no relationship between the amount of tea drunk and level of intelligence. What is scattergram? A correlation can be expressed visually. This is done by drawing a scattergram, also known as a scatter plot, scatter graph, scatter chart, or scatter diagram. A scattergram is a graphical display that shows the relationships or associations between two numerical variables or covariables which are represented as points or dots for each pair of score. A scatter graph indicates the strength and direction of the correlation between the covariables. So, what is the difference between positive correlation, negative, and no correlation? Again, positive correlation, the points lie close to a straight line, which has a positive gradient. This shows that as one variable increases, the other increases. While negative correlation, the points lie close to a straight line, which has a negative gradient. This shows that as one variable increases, the other decreases. In the no correlation, there is no important pattern to points. This shows that there is no connection between the two variables. When you draw a scattergram, it doesn't matter which variables goes on the x-axis and which goes on the y-axis. Remember, in correlations, we are always dealing with paired scores. So the values of the two variables taken together will be used to make the diagram. Decide which variable goes on each axis and then simply put a cross at the point where the two values coincide. What are the uses of correlation? It's for prediction. If there is a relationship between two variables, we can make predictions about one from another. Next is validity. Concurrent validity. Correlation between a new measure and an established measure. Next is reliability. Test-retest reliability are measures consistent, while inter-rater reliability are observers consistent. Next is theory verification. It's for predictive validity. Correlation coefficients determining correlation strength. Instead of drawing a scattergram, a correlation can be expressed numerically as coefficient ranging from -1 to +1. When working with continuous variables, the correlation coefficient to use is persons R. The correlation coefficient, or R, indicates the extent to which the pairs of numbers for these two variables lie on a straight line. Values over 0 indicate a positive correlation, while values under 0 indicate a negative correlation. A correlation of -1 indicates a perfect negative correlation, meaning that as one variable goes up, the other goes down. A correlation of +1 indicates a perfect positive correlation, meaning that as one variable goes up, the other goes up. There is no rule for determining what size of correlation is considered strong, moderate, or weak. The interpretation of the coefficient depends on the topic of the study. When studying things that are difficult to measure, we should expect the correlation coefficients to be lower. Example, above 0.4 to be relatively strong. When we are studying things that are more easier to measure, such as socioeconomic status, we expect higher correlations. Example, above 0.75 to be relatively strong. In these kinds of studies, we rarely see correlations above 0.6. For this kind of data, we generally consider correlations above 0.4 to be relatively strong. Correlations between 0.2 and 0.4 are moderate, and those below 0.2 are considered weak. When we are studying things that are more easily countable, we expect higher correlations. For example, with demographic data, we generally consider correlations above 0.75 to be relatively strong. Correlations between 0.45 and 0.75 are moderate, and those below 0.45 are considered weak. What are the strengths of correlations? First, correlation allows the researcher to investigate naturally occurring variables that may be unethical or impractical to test experimentally. For example, it would be unethical to conduct an experiment on whether smoking causes lung cancer. Next, correlation allows the researcher to clearly and easily see if there is a relationship between variables. This can then be displayed in a graphical form. What are the limitations of correlations? First, correlation is not and cannot be taken to imply causation. Even if there is a very strong association between two variables, we cannot assume that one causes the other. For example, suppose we found a positive correlation between watching violence on TV and violent behavior in adolescents. It could be that the cause of both these is a third or extraneous variable. Say, for example, growing up in a violent home, in that both the watching of TV and the violent behavior are the outcome of this. Next, correlation does not allow us to go beyond the data that is given. For example, suppose it was found that there was an association between time spent on homework, 1.5 hours to 3 hours, and number of General Certificate of Secondary Education or GCSE passes, 1 to 6. It would not be legitimate to infer from this that spending 6 hours on homework would be likely to generate General Certificate of Secondary Education passes. And that ends my discussion. Thank you for listening.